Hello and welcome in a new video. In this video, we are going to learn about the critical path method or CPM. This is one of the most widely used techniques in project management to plan and control projects effectively. And by the end of this session, you will know what is CPM and how it works and why it's important for project success. Okay. So let's start with the simple introduction. Here we have the introduction to CPM, and you can see it was developed in 1950s by the DuPont. Okay, and a scheduling technique to plan, coordinate, and control project activities, and it focuses on the longest path. Then it helps determine the project duration and task priorities. Okay. So CPM is a scheduling technique that helps us to calculate the minimum project duration by identifying the longest path of the activity. So it was first developed in late 1950s for the industrial projects, but today it is applied in construction, IT, oil and gas, and almost every type of project. So the key idea is delays in the critical path, delay in the entire project. Okay. So after that, we have here why CPM is important. Okay. So here you can see it identifies the critical activities, then shows the float or slack for the non critical task. Okay. So actually, CPM is so important in project management. And first, CPM identifies the critical activities in a project, and these are the tasks that must not be delayed because any delay in them will directly extend the overall project duration. Okay. Second, we have here the CPM help us to understand the float or slack in non-critical activities. So this shows us which tasks have the flexibility and which one are the strictly time sensitive. Okay. So third number you can see we have here the improve resource allocation. So it improves the resource allocation by knowing which tasks are critical and which have the float. So project managers can assign labor, equipment, and material more efficiently. Then at number fourth, we have provides the realistic project timeline. So CPM actually gives a realistic, product timeline instead of relying on the assumptions. So we get a clear data-driven schedule that reflects how the product will be actually progress. Okay. So in the last point, we have here the support delay analysis and claims. So finally, CPM supports the delay analysis and claims. If a project faced delays, the critical path provides a clear basis for analysis that impact and justifying claims for the extension of time. Okay, so in short, CPM is not just a scheduling technique, it's a powerful management tool that guides us in controlling time, resources, and even contract claims. Okay. So here we have next key elements of CPM. So here you can see first is the activities or tasks. So the first one is the activity. An activity is the you can say simply a specific task or a piece of work that needs to be done in the project. For example, pouring concrete for the foundation or installing electrical wiring. Okay. So next we have here the duration. So this is the estimated time required to complete an activity depending on the project. So this can be measured in hours, days, or even weeks. So after that, then comes to the dependencies. Okay, so it also called the relationship. So this shows that the link between two activities and the order in which they must happen. For instance, you cannot start the building walls until the foundation has been completed. Okay, so next we have critical path. So this is the actually sequence of the activities that takes the longest time to complete. So it also tells us the minimum time required to finish the project. So the critical point to note is if any activities, if any activity on this path gets the delayed, so the entire project will also be delayed. Okay, so in the last, finally, we have here the a float or slack, that is the flexibility in schedule. Actually, sometimes it's called float and sometimes it's called slack. Okay, so actually, this is the amount of extra time an activity can be delayed without affecting the project completion date. For example, if landscaping has a float of 5 days, so it can start late without causing a delay to the overall project. Okay. So there are the basic terms, and they are the foundation of CPM. So once you understand these clearly, analyzing and managing the project scheduling, schedulers schedules will become much easier. Okay. Next, we have here the types of dependencies. So, actually, in project scheduling, tasks are connected to each other through the through what we call dependencies, and these dependencies shows the a logical relationship between activities, and they determine the sequence in which task must be performed. So let's go through the main types. First, we have here, you can see that is the most common FS, or you can say the finish to start. So here, task B start after task A finishes. Okay, most common, that this relationship is the most common. Okay, so actually, this means that the task B can only start after task A has finished. So this is the dependencies we use most often in construction and engineering projects. Okay, the second, we have here the start to finish. Okay, so you can see here start to finish. Task B starts once task A starts. So in this case, task B can start as soon as task A starts. So both tasks run in parallel at least partially. Okay. So after that, on third point, we have finish to finish, means the FF, the task B finish once task A finished. So this means that the task B can only finish when task A finish. Okay, so the task may not be necessarily start together, but their completion is linked. Okay, so finally, we have here SF, start to finish. Task B cannot finish until task A starts. So this is the, you can say, rare type of dependencies, or you can say the relationship type. So here B, task B cannot finish until task A has started. So it's not commonly used in most projects, but it exists for every specific situation. Okay. So next we have here the steps in CPM. Okay, so we will follow these steps in CPM. First, we have here the list all the activities. So the first step is to list all the activities that need to be done in project. So, for example, in a building project, this could be include site clearing, foundation work, wall construction, roofing, and so on. Okay. The second, we have here the determined dependencies. So second step means the define the relationship between these activities. So in simple words, we need to understand which activity depends on another. For example, you cannot start building walls until the foundation is complete. Okay. So third point we have here estimate duration for the each activity. So this means deciding how much time each task will take, whether it's a few days, weeks, or even hours. Okay. So next point we have here the create a network diagram. So this diagram connects all the activities in their proper sequence. So it's like a roadmap that helps us to see the entire project plan clearly. So next we have here the perform forward pass, and we have here the backward pass. You can see here. So then we have identify the critical path and calculate the float. So uh, here you can see the identify the critical path and calculate the float. So the that is the the last point. Calculate the critical path. So this will be the longest path in the diagram, and it shows us the minimum time needed to complete the whole project, and any delay in the critical path activities will directly delay the project. So by following these steps, well, we make sure that no important activities are missed, and that our planning is realistic and well structured. Okay. So after that we have here the forward and backward pass. Okay, so these are the key steps in a critical path that helps us to calculate the early and late dates for each activity. Okay, so first we have here the forward pass, calculate earliest start and earliest finish. So the forward pass is used to calculate the earliest start, or you can say early start, even you can say es, and then ef means what, early finish of the activity. So in simple terms, it moves through the schedule from the beginning to the end, showing us how early each task can start and finish if everything goes as planned. Okay. So after that we have here the backward pass. You can see here backward pass calculate latest start and latest finish, ls then lf. Okay, so the backward pass works in the opposite direction. So it calculates the latest start and the latest finish times for activities. So this pass moves from the end of the project back to the beginning. So telling us how late we can start off, or you can say finish a task without delaying the overall project. Okay, so here we have the simple formula. You can see float equal to late start minus early start, or you can say late finish minus early finish. Okay, so critical path activities with the zero flow. I hope this is clear. Okay, so next we have here the example. This is this you can say simple example for the CPM, or you can say simple networking. So you can see here we have here the task. Here we have the activity A, and it will take the 3 days. Here we have the duration. So next we have activity B that will take 3 days again, and next we have a C, and it will take 6 days, and then we have D, it will take 8 days. Then in the final we have E that will take 4 days. Okay, so here you can see that we have actually two paths here. The first path A, B, D, and E, and then the other path we have here A, C, and E. Okay, so now let's calculate the total duration. First, let's calculate the A, B, D, E. A 3 plus 3 6, and then you can say 8. There will be 14. Then 4 plus 4, we will have 18. So path first path have 18 days. Okay, and then second path A, C, and E. 3 plus 6, 9, 9 plus 4, we will have 13. So second path have 13 days. Okay, first path, you can say first path have 18 days, then second path have 13 days. Okay, so from the calculation it is clear, that 18 and 13. So now if you focus here, so it's very important. This will be the longest path. That path have the more duration. I mean A, B, D, and E. Okay, and the other, you can see the other path ACE takes only 13 days since the project finished in 18, and so this path has a float of 5 days of you. If you do minus from the 13 out of 18, so there will be 5. Okay, so this means activities in the critical path can be delayed by up to you can say sorry, this means the activities in this path. I mean the path B, A, C, and E. You can have the 5 days cushion, or you can say 5 days float. Okay, it's mean you can delay 5 up to 5 days. Okay, so in this diagram, the critical path is highlighted in red. You can see here. This is the red arrows, relationship types, making it easy to see which task must be carefully monitored and controlled. Okay, so you can see here show all the small and network. Here I have just explained in a very simple way. Okay, I hope this example is enough. So next we have here the CPM versus PERT. Actually, PERT is the program evaluation and review technique. PERT is also the methodology of project management. CPM is the also methodology of project management. Okay, so first, we have here the feature CPM, then PERT focus. In CPM, we focus time and cost optimization. PERT time uncertainty. Then activity duration deterministic. That will be the fixed, and in a PERT, the probabilistic, optimistic, most likely, then pessimistic. So we use a formula for the duration in PERT. Okay, so here we have the usage. We use the in construction, EPC, and IT projects, then R&D, and the product development. Then critical path based on the fixed duration based on the probability distribution. Okay, so this was the very simple difference between the CPM, I mean critical path method, and uh, PER means the program evaluation and review technique. So both are the actually project management techniques. Okay. So next we have here the advantages of the CPM. So here you can see clear the visualization of product flow. So first, CPM provides a clear visualization of the product flow by using a network diagram. It becomes much easier to see how activities are they connected, and which task is critical, and how the product will progress step by step. Okay. Second, identify critical versus non-critical. So it helps us to differentiate between the critical and non-critical tasks. So this is, you can say, the extremely valuable, because it tells the project managers where to focus attention, and and which task have the flexibility. So Third, we have improved decision making. So the CPM improves the decision making with accurate information about duration, dependencies, and flow. Managers can make informed choices about the resources allocation, scheduling, adjustment, and risk response as well. Okay. So next we have here the use for the delay analysis and EOT claims. Okay, so that's the key benefit, you can say, of the CPM, that delay analysis and extension of time claims. So since CPM clearly defines the critical path, it provides the evidence needed to analyze delays and support claims in the contractual disputes. Okay, so this is very important. So finally, we have here the CPM is widely spotted in the professional software like a Primavera P6 and MS product. And so these tools not only the calculate CPM automatically, but also provide advanced reporting and tracking features, then making CPM highly practical and reliable for modern project management. Okay. After that, we have here the limitation of CPM. So a CPM, have some limitations. So you can see here it relies on accurate duration estimation. Okay, so it depends heavily on the accurate time estimation. So for the large projects, the network diagram can become very complex. Okay, so don't you can see here they don't directly handle the resources constraints and may require regular updates. Okay, so that's why. In a real project, CPM is usually used along with the other tools like the cost control techniques and risk analysis, etc. Okay. So next we have the practical use in software. Okay, so the tools like Primavera P6 and Microsoft Project make the entire process much easier. You don't have to manually calculate forward pass, backward pass, or float because the software does it automatically for you. Okay, so Primavera P6 and MS product are automatically calculate the CPM, highlight critical activities in a red, then provide the float analysis for resource optimization, then essential for the project controls and delay claims. Okay, so actually, in tools in Primavera P6 and MS Project, critical activities are automatically highlighted in a red, so you can quickly identify which task must not be delayed. Then the software also provide a float analysis, helping project managers to optimize resources and adjust the schedules without affecting the final completion date. Okay, so most important, CPM in these tools become the foundation for product controls. Okay, so it allows you to monitor progress for cost delays and most critically prepare or defend delays claims and extension of time request. Okay, so in real world practices, you can say CPM is not just a theoretical concept; it is an essential feature of scheduling software that support both the planning and claims management. Okay, so finally, we have here the conclusion. Here under the conclusion, you can see CPM equal to backbone of project scheduling, then identifies the critical path and project duration, then helps in planning, monitoring, delay analysis, and claims. Then use worldwide in construction, EPC, IT, and manufacturing. Okay. So the critical path method is one of the most powerful scheduling techniques in project management. It helps us to identify the minimum time to complete the project, then show which activities are critical and support better decision making. So As a future product manager, you will be using CPM either manually or in small projects or through software like a Primavera P6 and MS product in large products. Okay, so this was the overview of the CPM in product management. I hope everything is clear. So thank you so much for watching this video. See you in the next video.